Right, hello everyone. It's great to be here. I've heard so many good things about this conference, so it's a real treat to be speaking to you. My name's Anselm. I run a little company called Garden Computing, and like Ryan said, we're building something called Jazz. But before I get into that, the first thing you need to know about me is that I really believe that frontend is harder than backend. And in fact, when people say that like LLMs are bad at frontend, I'm like, are they really bad at frontend, or is frontend just harder than backend? The reason that I believe frontend is harder than backend is because of my many years in the SaaS mines. Let me explain. In a time long ago when we were still writing code by hand, I was churning out one full stack app after another and kept going through the same motions over and over again. You start by mapping out the domain model, like what is the app actually about. That's hard and usually most of the conceptual work. Then you come up with the user interface and build the front end. This is also hard because you need empathy both for the users and for the people who invent the CSS standards. And then usually I build a quick, mostly working demo around local UI state because that's really easy to iterate on and show to the customer or client or your boss early on. But then, of course, you actually have to make it work. And I always felt like this was now just busy work because even if the backend needed to do complicated business logic and integrate with arcane external systems, everything was already kind of mostly determined by the first two steps. The database schema was clear from the domain model, and the backend mostly needed to make data available to the front end and do some auth and checks maybe. It really felt like all the backend did was shuffle data between the database and the front end, and seeing that again and again got really boring. Again, front end is harder than backend. But suspiciously for me, the front end was also the fun part. And if the fun part solves most of the problems, why is the rest such a drag again and again? This tragic situation kind of sent me into an existential crisis. And if you're in an existential crisis, you got to think some new thoughts and build some new stuff, even just to prove to yourself that a better world is possible. So I got fixated on one fact. Building the flashy demo around local state felt fun and meaningful, right? What if it was fun because local state was easy? Thinking new thoughts is often very childlike, so kind of like a toddler, I wanted the most immediate, unrealistic solution that would instantly, magically fix everything. So I asked myself, what if my database simply looked like useState? That's what I started building, and that's what became Jazz. It turns out that other people had similar ideas and also wanted to simplify the stack similarly. This is now the well-established category of real-time databases and sync engines. I'll first describe what these technologies roughly have in common because the most important idea is that there is a new kind of stack and it looks generally like this. And after that, we can dive into the more uniquely Jazz things. But for now, the main message is you deserve a better stack. The three metrics I want you to keep in mind when you judge a stack are lines of code, especially the ones that don't really make your app unique. Layers of infra bullshit, meaning how many things do you have to deploy and integrate with each other? And finally, light milliseconds that user edits have to travel before they become visible. Now that you know the metrics, let's get to work. I'll take you on a journey where we start with a traditional stack and watch layer by layer get subsumed by some or all of the more modern alternatives. This is our starting situation. And this is exactly what makes the backend part unfun. You see in the backend, we've got the database, connection pooler in front of it, ORM, caches in front of that, some queue system, your backend framework, of course, a lot of boilerplate just to make CRUD work in the API, auth logic, workers. And even the front end is quite complex. You all know like data fetching layers. If you do real time, you need to think about WebSockets usually. There's some kind of caching for the data fetching and maybe optimistic updates. It's a lot, right? The first thing that these modern systems usually collapse is the front-end sync glue. Data fetching and the WebSocket client kind of disappear as concepts, and the query cache plus optimistic update layer start getting absorbed into one database-shaped client abstraction. So the first great thing is that the front end starts feeling like it is working with reactive data instead of orchestrating remote state. Lines of code go down immediately, and on the light milliseconds metric, we get our first huge win. Because we can have optimistic local previews built into our client, the interaction latency kind of goes to 0 for the cases where that makes sense. Next, the backend's database access story starts simplifying too, because the ORM or classic database wrapper gets replaced by a more integrated database client. This only saves a little amount of code because we're mostly swapping out one abstraction for another, but it definitely simplifies the shape of the whole system. You stop having a database model on the server and a completely different access model on the client, and it normalizes the idea that, yes, a database client can live in the front end directly too. Then some of the scale and performance crutches start falling off. One obvious example is the connection pooler, because traditional databases didn't assume lots of clients or backend function instances or, God forbid, agents connecting directly. So that's better now. And we're not removing much product code here, but again, we're deleting operational surface area, which matters a lot. Then you start seeing the messaging and fan-out layer move inward too, like things like queues, pub/sub, real-time distribution, durable streams, that are all kind of different products that you usually integrate, now become part of a database that's just inherently a real-time coordination system instead of just passive storage. Some systems go further and also absorb files or blob storage. Again, not every tool does all of these steps. This is not like a perfect consensus feature list. But the direction is that more and more of the app's surface data gets pulled back under one roof. And then permissions move inward too. Instead of auth being something that the backend wraps around every query, the database itself starts understanding auth policies. This means a whole chunk of backend auth glue disappears, along with that extra auth round trip between the backend and the database. At this point, the stack is already much cleaner than what we started with, right? So let's pause here and look at what's left. This is already pretty clean. This is roughly the shape that modern real-time databases and sync engines are converging on. And that alone is already a huge improvement over the traditional stack. Now comes the Jazz-specific part, because our ambition is not just to make the backend slimmer, but to get as close as possible to that feeling that useState is your database. The next question is, if we've already made it this far, what else can we do? One answer is that we can get much more aggressive about latency. So instead of a dumb cache, Jazz adds built-in regional edges for caching and very low latency collaboration between nearby users, like in the same city. That gives us another mode on the light milliseconds metric, where you don't just have full remote state or optimistic previews, you have actually genuinely short regional paths. And unlike a normal cache that is bolted onto the side, this thing is aware of the data model and auth model, which matters because otherwise these low latency layers quickly turn into yet another source of glue and inconsistency. Just think about the problems of cache invalidation and the kind of security issues that we've had because caches bypassed authorization. You can actually get approximately this with traditional stacks too, but only if you happen to live in US East 1. Now it gets really interesting, because we stop treating the client like just a fancy cache with optimism and introduce a truly durable local-first database on the client. And at that point, the dream of useState being your database starts becoming real in a much stronger sense, because it's not just reactive, it's not just optimistic state for some remote backend, but you actually have durable, offline queryable state as part of like a whole integrated system, right? This is kind of how far we got with Jazz the past 4 years. And we found a bunch of adopters who really fell in love with Jazz and the idea of local first state. They built some of the coolest stuff, like from language learning apps to Uber for robot teleoperation, social networks, a Figma killer, and a ton of personal software with like insane production value for single developers because they could actually focus on the front end and the things that really make their app their app. But that's kind of the moment where the easy story ends and the hard story begins, because once the database is truly local first, a whole new class of problems shows up. And these problems point at ways in which durable databases simply truly are different from ephemeral local state, because now you've got multiple users writing to the same data. Like, what if eventual consistency isn't enough and you need global transactions? Should you use a second database just for that? Yuck. And it's usually pretty easy to enforce permissions in a centralized database with an API in front of it that enforces those. And we came up with this crazy system for local first permissions in the old version of Jazz, but it was way too confusing for people. Same for schema evolution. Changing the shape of ephemeral useState is easy because like you refresh the page, it's gone, whatever shape changed, right? But once data is persistent on different devices, things get tricky unless you're extremely careful about trying to stay backwards compatible. And more our adopters kept asking us about exactly these challenges. And it's not like we didn't have any answers to those in our API. They just felt much worse than how great the rest of the API felt. So once again, I found myself in a situation where some things were really good and others really felt unnecessarily hard. And by the end of last December, it had turned into another existential crisis. It was time for some fresh ideas again, to unreasonably ask for the impossible like a toddler again. And because we're all roughly equally insane, everyone in my company was immediately on board on taking a really big swing. So we started working on it, but the problem was that we didn't have much time. You see, like React Miami already accepted this talk where I promised that I'll have a database that works like useState. And we knew we couldn't present something that, where we didn't have all the answers. But in 4 short months, we pulled through, and today I'm very happy to announce that we're so back, we figured it out, and today, just for you guys, we're launching Jazz version 2 alpha. Thank you. Let's take a look at the 4 fresh ideas that went into Jazz v2 to actually make local first work. You see, they correspond to all the ways in which shared state is actually different from local state. And I like to visualize them as new spatial dimensions that Jazz is giving a database. What do I mean by this? If you think about it, a database is obviously 2D, right? Tables got columns and rows. And in a traditional database, you have one instance of this table. But here in Jazz, we have a local version of the table, maybe with a subset of the rows that this client cares about, and then a much bigger version of the table in the cloud. And here we get sync as our first new dimension. And our first fresh idea is all about sync. It's a simple compromise. In classic Jazz, we learned again and again through adopters that surprisingly, actually, eventual consistency is fine for 90% of interactions in most apps. It's usually okay if for a short moment different users see slightly different versions of shared data. But the exceptions matter, like only one user should be able to buy the last ticket for React Miami, right? And we don't want to add a whole second database just because some corners of the app need global consistency. So Jazz lets you choose per table whether eventual consistency is okay or whether it needs global consistency. So you can trade latency and offline support against consistency where it actually matters. You as the app developer know best, right? And you shouldn't be limited to one kind of consistency per database. The next idea is even more essential for making local first work, permissions. In traditional backends, the boundary is clear. You enforce permissions at the API in front of the database. But here we have local state and direct sync to the database itself, so the database itself has to understand permissions. For this, we rely on a proven concept, row-level security. It lets you define permissions as queries that look like your normal queries in one centralized testable place. This means that the database can enforce permissions at sync time. Even better, the local client also knows how permissions work and can preview what the current user can and can't do before the round trip so you get no weird glitches. And this is why I think that row-level security is a good idea. Wait, what's this? Emergency alert, your normal take is now a hot take. So this happened a couple days ago. It all started with David's post. And I'm like, well, after a decade of using row-level security in Postgres, I was pretty happy. It seemed a good idea for the reasons that I said. But I learned quickly that many people had a much more mixed experience with it. And what I also learned is that a big part of that seems to be that it's hard to get right in Postgres, honestly. And in Supabase, people often start from everything being public because that's the default. And a bunch of apps where people maybe vibe coded a bit too close to the sun leaked a bunch of user data just because that's the default. So I have a lot of thoughts about this. Expect a blog post, basically. But the short version is that our goal with row-level security in Jazz is that the policies are easy to get right. You have to have them. Everything is locked down by default. They're not an afterthought. They're really built into all of Jazz, and they're tightly integrated with external auth. Moving on, let me show you one of the most unique fresh ideas of Jazz. This is about the hardest part of local first data, changing the shape of your data as the app evolves. You can't do a good old stop-the-world migration in a central database because there might still be old clients expecting the old shape. Usually, backwards compatibility is also the API's job. See a pattern here, like if a client syncs directly to the database, now the database needs to be responsible for backwards compatibility too. So in Jazz, we turned migrations into something slightly different. Instead of a one-time event, migrations describe a mapping between two schema versions. And it's bidirectional, so we can translate both old data into the new shape for new clients and new data into the old shape for old clients. And Jazz does this just in time instead of making you stop the world. And then we realized something important. Bidirectional migrations are not just a solution for changing the shape of local first data, they also make it much easier to deploy schema changes for any app. The same idea lets you work on 10 features at once with your horde of clouds, or it removes a central release bottleneck in a large company with many teams launching different features, maybe even behind lots of feature flags. Making all of that automatically compatible is suddenly much easier with what we call fluid migrations. So taking it all together, while traditional databases are playing checkers, with Jazz you're literally playing 4D chess. But now you might be wondering, Anselm, we're still one fresh idea short. Well, what if I told you there was a fifth dimension? And this is the one I'm most excited about, because what if every row in your database had history? Because in Jazz, every row in your database actually has automatic history, and it auto-captures precise edit metadata of when each row was last updated and by whom. This makes it much easier to build complex collaborative features while your UI still only does what looks like a simple local state update. But it gets even better because each row has not just linear history, but branching history like Git. In the simplest case, this makes the tricky problem of people editing data at the same time actually tractable. And it's actually even better than Git because it lets you choose precise merge strategies per column, like do you want to merge JSON here, or is this a rich text column that should be smart about that? Again, if you wanted to build any of this before, you could combine a bunch of different collaboration libraries and real-time networking stuff, but it's a lot of glue code and it would nudge you into one model. Here you get it all in one system and you can choose the behavior in detail that makes sense for your app. But maybe people editing things at the same time isn't something that really happens in your app. Maybe it's a slower paced one where many people and their agents interact with shared data over like a longer time horizon. And for that, wouldn't it be cool if you could expose this better than Git model directly to your users? Well, in Jazz, it's backed directly into the data itself. And I think personally, like, this will enable the most interesting new kinds of apps. And that's why this is my favorite new dimension that we're adding. All right, do you want to see what this looks like in action? Let's take a quick look at a super simple Jazz v2 app. We'll build a shared canvas with multiplayer cursors where everyone can drag some letters onto the canvas and drag them around. We'll start with a data model. It's simple enough. We have canvases and cursors and letters associated with the canvas. And each cursor belongs to a user, but note how we don't have to add a user column to cursors because, again, we have magic built-in added metadata for that. How do we render the state? It's also pretty simple. We just use the useAll hook, which reactively subscribe a component to a query with some filters. For example, like we only want the cursors and letters on our canvas that we care about. And under the hood, this reads local data and triggers sync from the Jazz database upstream, which sends us any existing state that we don't have yet, plus live updates from other users. But to us, it really just looks like reactive state. Mutation is also super simple. Just get a database handle from useDB and then insert or update data. And all of this is type safe from the schema, by the way. You get nice autocomplete. And last but most importantly, we have permissions. Jazz, like I said, actually makes you define them and fails closed otherwise. We also really tried to make the DSL readable enough that you can see at a glance whether you set them up correctly. For our app, everyone can create a canvas, everyone can add letters and move them around, but cursors can only be updated by the user that created them. Makes sense, right? For more complex apps, Jazz gives you a whole permission testing framework around this, so you can set up tricky situations and edge cases without having to end-to-end test your whole app. This is really important for helping agents get permissions right. Should we attempt to try it? Here it is as an actual app. I'm on my phone internet connection. I'll see if this loads. This looks good. See if you can load this QR code. If the conference Wi-Fi is bad, please try your mobile connection. But what we can do here is you can see we have real-time cursors, and I can grab some letters and put them onto the screen. And oh, we've got our first. I don't know why I can't see your cursors, but can I drag around your letters? I totally can. All right, sweet. If you're interested, we can try this demo again later with better internet, because we should really see everyone's cursors going around like mad. But for now, that's what that apps look like. There's really not much more code to it than what you saw. And I hope this gives you a good idea of what does it actually look like in theory and in practice if useState is as close as possible to your database, or your database is as close as possible to useState, plus all the extra cool stuff with the extra dimensions. So if you like this and you're wondering, what if my database was useState, or you're wondering what if my database was Jazz, the best way to try out is to just run npm create Jazz. We've also got our very work in progress new homepage with docs at jazz.tools. You can follow us at jazz.tools on Twitter, and please join our Discord. Let us know what you think, especially if you've tried other alternatives from the real-time database and sync engine sphere. You hate some things, you love some things, let us know. And thank you very much. Thank you.